Select the best set of reaction conditions to accomplish the following transformation. So we are given a starting material and we are given a desired product. So we want to look at what's changing in this reaction. So let's start by looking at our starting material and seeing what it is. And we see that we have a diol, so two alcohols. And then we want to decide what type of alcohols classified based on their substitution. So we have at this carbon center, that carbon is bound to two other carbon atoms. So we have a secondary alcohol. And we have also an alcohol at the end of the chain. It has just one bond to another carbon atom. So that is a primary alcohol. And if we look at our product, we're increasing the number of bonds to oxygen. So these are both oxidations. So we are doing an oxidation reaction here. And so we want to see what our alcohols are becoming once they're oxidized. So we can see that our secondary alcohol, this carbon atom right here, has become a ketone. And our primary alcohol has become an aldehyde. This is the important piece of information. Secondary alcohols can only be oxidized by ketones, two ketones by the methods we've learned in this reaction. Primary alcohols can be oxidized to aldehydes. So you can take a primary alcohol and oxidize it to an aldehyde. Aldehydes still have a hydrogen to that carbon, and so they can be oxidized further to give you a carboxylic acid. So with the reaction conditions that you have seen, we know that chromic acid will take a primary alcohol and oxidize it all the way to a carboxylic acid. All of the other conditions that you saw in this chapter will take a primary alcohol and oxidize it to an aldehyde. So conditions that would do that would be PCC in dichloromethane. Hypochlorous acid is another set of conditions that would do this, or the Swern oxidation would also take a primary alcohol and stop it at the aldehyde. So if we take a look at our reaction conditions, the first set, these are conditions that will combine to give you chromic acid. So we definitely don't want that one. And if you look at B, that's the PCC in dichloromethane. So that will work to go from a primary alcohol to an aldehyde. Options C and D are actually reducing agents. So these are reagents that you'll be introduced to in the second semester of organic chemistry that will essentially allow you to do the opposite direction reaction.